right, so this is day 3 of quantitative data, and so we're still summarizing everything. So we did shape, we did center, we did spread, and today the focus is going to be on our O. And remember, it's outliers and any unusual features. And this could be a gap in the data, it could be a cluster of the data, anything that is just abnormal that gives you a break in data, okay? So it says the most common method for identifying outliers in a distribution of quantitative data is based upon a resistant measure of variability. So which measure of variability is resistant? And that is IQR. And that's where when we're dealing with RQR, we're using that if we've got extreme values. So anything that's on the high end or the low end. So how do we identify that? So we have this formula, and what you're going to see is it's always going to be checked by the 1.5 IQR rule. So if we have a low outlier, then our formula for that is going to be less than Q1 minus 1.5 times IQR. And we know that IQR, just kind of a little review, is Q3 minus Q1. And we're going to get this from our 1var stat from the calculator. So we're going to plug a number in. We're going to get our IQR. We take our Q1 and we subtract 1.5 of the IQR, and we compare that value with our lower values. If we have a high outlier, this data is going to be anything greater than Q3 minus 1.5 times IQR. So let me just draw a little picture here. So if you remember, this is what our box plot looks like. And this is our Q1 value, and this is our Q3 value. And this right here is our IQR. It's that middle 50%. So if we have a low outlier, it's going to be Q1, which is right here, minus 1.5 times this IQR. So some value that's going to be over here somewhere, okay? And if we want one that's bigger, it's going to be greater than Q3 minus 1.5 times IQR. So we're checking to see if we have a value that's out here. So that's kind of what that looks like. Okay, so we have a problem here, and it says catamarans are boats built with 2 hulls so that they are very stable because they have a broad beam width. Certain catamarans are built to withstand passage across open oceans. One important characteristic is freshwater capacity, measured in gallons. Here is freshwater capacity of a sample of 19 ocean-going catamarans. Use the 1.5 IQR rule to identify if there are outliers in the distribution. So, first thing that you need to do is go into Stat, and then go into Edit and put your data in. And just to save time, I already put my data in, so it's all there already. So once you've got your list, you go into Stat, you arrow over to Calc, you run your 1var stats. Okay, so here's my data. And if I need IQR, then I have to go get all of this information. So what I have here is that my Q1 value is 145, and my Q3 value is 206. So this makes my IQR 206 minus 145, which is 61. So if I'm checking for a low outlier, this is going to be a value that is less than Q1, which is 145, minus 1.5 times 61. So here's my Q1 minus 1.5 of my IQR. Then I'm going to check for a high outlier, and that's going to be a value that's greater than Q3, which is 206, minus 1.5 times 61. Now, here's the thing. When you're doing this, you have to remember that the IQR rule means you're going to use Q1 for a low outlier and Q3 for the high outlier. And it's not going to tell you that. This is just a formula you're going to have to memorize. So I would tell you, make sure you go up here and you know these 2 formulas. So if I plug this in my calculator, I get 53.5 for this value. And if I do this one, oh, shoot, guys, this should be plus. Holy smokes. Because I want a number that's greater, times 61. And that is Oh, I did it wrong. Hold on. 206 plus 1.5. Oh my goodness, I'm struggling today. 297.5. All right, so here's what this is telling me. Anything that is less than 53.5 is going to be an outlier. Anything that's greater than 297.5 is going to be an outlier. So now we just go back up here and look at our data. And if we look at our data, this is 79. That's our lowest number, which is greater than this. So we have no low outliers. Okay, so now we want to find, do I have any numbers greater than 297.5? And I have this one, yeah. So I have a high outlier at 360, and then I'm just going to say because 360 is greater than 297.5, and it's okay to use this math speak right here. So if I identify what I'm doing on this, I would say that in context, the catamaran with freshwater capacity of 360 gallons is a high outlier. Now, what we had when we were describing the distribution, so one of the earlier lessons, is we would look at a distribution of data. I could take all of this data. In fact, I can do it right now. I can take this data and I can plug this in here, and I can graph this. And here's my histogram. So if I look at this histogram, which is the data that I already had here, here's my histogram. And when we describe the distribution, remember we said we have a potential outlier out here. This is going to be our 360. Well, now we have a way to mathematically justify that. So now we wouldn't just say we have a potential outlier. We would say we do have an outlier, and that outlier happens at 360 because 360 is greater than 297.5. Okay? So there is another method for determining outliers. And this other method is if you have a variability of standard deviation. So if our variability is standard deviation, then this means that the center that we're using is going to be our mean. And the rule for this is a 2 standard deviation rule. All right, so here's what that looks like. So my low outlier for a 2 standard deviation rule means that the outlier occurs if it's less than the mean minus 2 times the standard deviation. And our high outlier is going to be greater if we have the mean plus 2 standard deviations. So we know that we were using IQR on this top one, but if I go back over here and I run my 1-bar stats again, I have my standard deviation, and my standard deviation that it gives me here is 65.497. So if I wanted to run this, oh, and it gives me a mean on my X bar. So my X bar here is 174.58, and my standard deviation is 65.497. So if I want to plug these numbers in, I would have my mean, which is 174.58 minus 2 times 65.497. And what I get here is 43.59. And if I look at my, so this would be my low. If I look at my high, I would have 174.58. I'm using the same numbers, and now 265.497. So same formula, but this time I'm going to be adding, and that tells me that that happens at 305.57 So if I look back up here, excuse me, if I look back up here at my data, again, the only value that hits that is 360. Okay, now normally what we're going to do is we're going to use this IQR rule, but if it doesn't tell you, you really have the flexibility to use either one. It normally tells you 1.5 times IQR, but you have to think about if we had already graphed this data and we saw our graph, we could say, well, we could potentially have an outlier, so because of that, you would have chosen to use the IQR rule anyway. Okay, so again, that's why looking at the shape is super important, so we know if we're using median and IQR or if we're using mean and standard deviation. Okay, let's keep going. So unless otherwise, and this is what I just said, unless otherwise indicated, use the IQR rule to identify outliers because it's based on statistics that are resistant to extreme values, unlike the mean and standard deviation. Okay, all right, so it's important to identify outliers in a distribution, and as we're doing this, one of the reasons why we want to do this is because the outlier might be just inaccurate data. You see how fast I type this in my calculator. I'm sure you guys are even faster than I am. And so because of that, it's very common for you to have a mistype in there. And so it might show that you have an outlier, but you really don't. So be careful. So outliers can indicate a remarkable occurrence. There might be something that happens in the data set and you'll be like, okay, well, that was a predicted outlier. So you might want to strike that data point, okay? How outliers can heavily influence the values of some summary statistics. And this is key right here. We're going to talk about what summary statistics are in just a second, such as the mean. So we know that an outlier influences the mean because remember, if you look at our curve, if we have something that is right skewed, our mean is going to be up here and our median is going to be here. So outliers, could be potential outliers out here, would affect our mean. It affects the range and it affects the standard deviation. All right, so we have already talked about box plots. But we're going to talk a little bit more about box plots. So a graphical option for quantitative data is a box plot. I love these because I think it shows a lot about where your data is. The box plot summarizes a distribution by displaying a local 5 important values. So what you'll see all the time is this is written, in fact, I'm getting a highlighter because this is so important. This is going to be written as identify the 5-number summary. So let's go back to our same data here on our calculator and go back and run this one more time. So I'm going to run my 1var stats one more time. And now I'm going to go down here and I'm going to look at all of the data that I need. So what makes up our 5-number summary? It's all this data. So I have my min, and my min happens at 79. I have my Q1, which is 145. I have my median, which is 158.5, my Q3, which is 206, and my max, which is 360. So these are the 5 numbers that make up, and they call it the 5-number summary, but it's what makes up the box plot. So if I was going to graph this, I would have my low value here, which is 79, and then I would have this value here at 145, that's my Q1. And then I have a value here at 158.5, that's my median. And then this value here at 206. And then all the way out here, I have this value here, which is 360. Okay, so I'm going to talk about this for just a second, because when we have a data point that is an outlier, we write our box plot a little bit differently. And so again, this is my min, this is my Q1, this is my median, Q3, and max. Now, because we know that this value of 360 is an outlier, we just calculated that, we know that, we're going to draw this just a little bit different. So with an outlier, our box plot looks like this. 179, 145, 158.5, 206, and out here this value is 360. Now, I would need to know what my next highest value is. So, looks like 264. So this value here now becomes 264. So this is my new max value, but technically it's because I have this outlier at 360. So when we have an outlier, we're going to use an asterisk. I don't know how to spell that. So just use that asterisk to identify your outlier. And it could be a low outlier. You might have more than one outlier. If you do, you would put 2 asterisks in there, right? If you had 2 low outliers, you'd put 2 in, and then this would be the value that's in your range. Okay. All right. So we have another example here. It says we hear that the typical depth of an ocean is greater than 2 miles deep. Is this true? To investigate this claim, 14 randomly chosen locations were selected from the ocean, and here are your depths. Make a box plot to display the data. Okay, so what I'm going to do, I'm going to go ahead and pause this, and I'm going to let you do this one on your own, and then I'll do it, and I'll bring it back up, and we can check your answers. All right. So I put the data in, I ran my 1var stats, I calculated my IQR, and I looked at my outliers. So I'm going to draw this out now. So I'm going to draw this number line first, and I'm going to say this is going to be 0, and this is going to be 1K, 2K, 3K, 4K, 5K, and 6K. So I try to make this as even as I could. So here's what I'm going to do. I'm going to look at my low outlier. So my low outlier is at anything less than 1006. So I see I have this value and I have this value that are both low outliers. So I'm going to have an asterisk here at 205. I'm going to have an asterisk here at 747. So those are my 2 outliers. And then my next lowest value, it looks like it's this one, 1372. So right here at this, sorry, this should be a dot. This is my value here at 1372. This is my new min. My median happens at, my Q1, let me go here. My Q1 happens at 34.99, so almost half. So this is my Q1. And then my median happens at 40.30, so it's going to happen really close here. And then my Q3 happens at 51.61, so it's going to happen right in here. So here's where my box comes in. Here's where my lower end whisker is, and my max is 6,006, which is less than 7, so this is not an outlier. So this is my max, and it happens at 6,006. So if I put these numbers in here, 4030.5, and this is 5161. Now, the reason why I wanted to draw it this way is because this shows you that even though this scale's not 100%, we see a difference. We know this is 25% of the data, and this is 25, and this is 25, and this is 25. So we see that this little box right here is 25% of the data, right? And so what this does is it gives you a better picture of where the majority of our data lies, okay? So make a box plot to display, that's what this would look like. So second part, and this is why we do these graphical analysis so that we can make a claim. Does the graph in part A support the claim that the typical depth of the ocean is greater than 2 miles? Explain your reason. So what this is saying here is, does it support the claim that the typical depth is greater than 3219? Well, if you look at this, 3219 is going to be in here somewhere. So this is where 3219 would be. And we have all of this data that is going to be greater than 3219. So I would say, does this support the claim? I would say yes, more than 75% of the data is greater than 3499 meters. Now, I don't want to use this number. I'm using 3499 because that's the number that I have up here in my my Q1 value. So what we can say here is that the median of 4030.5 meters is greater than 3219, showing the, let me get this, the depth of the ocean is skewed right. Now, remember, if it's skewed right, that means that we're driving it towards the deeper end, okay? All right, so box plots. Box plots provide a quick summary of the median. And the median here is my center, and the variability. And the variability here is my spread. And that comes in the form of IQR, okay? All right, so box plots don't give a complete picture of the shape of the distribution because they do not display each individual data. What features of the shape of the distribution can we not identify by looking at a box plot? So we look at this box plot. What don't we know? Well, we can see that we have outliers, but we don't know if we have peaks. We don't know if we have clusters or gaps. We could put all of the same data that we did here to get the 5-number summary. We could put that into a histogram and look at it, or even a dot plot and look at it. But if we look at just the box plot, that's what this is saying. Looking at just the box plot, we don't see these things. Okay? All right, that's it for today.